Okay, so after our partial fraction decomposition from earlier, we can now go through and take our inverse Laplace transform. And in doing so, we're going to have little y of t is equal to -1/9, which is just a constant because it's 1 over s, plus 1/3 t plus 37/9 e to the -3t. And then back here, we have to be very careful because we have to make sure that we shift everything because of this heaviside term. So we're going to have a -5/9. It's a constant, so shifting a constant keeps it the same. But minus 1/3, instead of being a t, it's going to be t minus 2. And then we're going to have a plus 1/3. And that's going to be e, normally to the -3t, but it's going to be 3 times t minus 2. And this whole thing is multiplied times the heaviside at t minus 2. So that's our inverse, and now we have to go in and express this as a piecewise defined function that changes definition at 2. So the y of t is going to first have our -1/9 plus 1/3 t plus 37/9. That's not very nice looking. Let's erase that and fix it. All right, so plus 37/9 e to the -3t, and that's for t values between 0 and 2. And now for the second piece of this, we're still going to have this entire first 3 terms part of our solution because they are still going to be in play. But now because the heaviside value takes on a 1, we're going to also have these 3 terms as well. So we're going to have -5/9 minus a 1/3 t if I distribute, plus a 2/3. Again, that should be a 3 there. And that's e, just plus 2/3, and then plus our 1/3 e to the -3 t minus 2 in parentheses. And this part of the definition is for t values that are greater than or equal to 2. The next thing you'll notice, which is not a coincidence here, but it's because of our problem, if you go in and actually add up our like terms in our second part of our definition, you'll notice that the 1/3 t's are going to cancel out, and so do the constant terms cancel out as well. And that happens because there's no forcing term when t is greater than or equal to 2. If you think back to the start of the problem, it was equal to 0. So this function here actually simplifies quite a bit. It has the first 3 terms, as usual, are -1/9 plus 1/3 t plus 37/9 e to -3t when t is between 0 and 2. But then it's going to only have the exponential terms when t is greater than or equal to 2. Okay, so that's our solution, and in the next part of the presentation, you'll see us actually graph it.